Okay, we just finished the lecture material on these polar coordinate problems where we're dealing with arc length and area. I got to tell you, the worst things about doing these things over here is one, probably the visualization, drawing them. At least for me, I don't like graphing. And the other thing is what are the limits of integration for these problems? And that often throws me in a tizzy sometimes trying to find out what I have to do. All right, so we went through some examples already, but now we're going to, move forward and we're going to do the problems here. All right, so remember those little videos on the side. If you need to watch those, you can. But I will go through these examples over here, and certainly one at a time. I'm hoping they go pretty smoothly for us. Again, I want to repeat this. I'm not beyond making mistakes. And the reason I tell you that is that you guys are not beyond making mistakes. The biggest mistake people make is they really don't spend enough time in the study department. And that's the biggest mistake people make. All right. So let me go to the share. I'm going to share my whiteboard with you, and we'll start the problems. And again, I hope they start off, relatively simple. So this one over here, if this is an exam question, what I would recommend you do, I would draw a picture first. And what I notice about this guy over here, just, excuse me, just, quickly looking at it, I'm going to notice that it doesn't appear to be a difficult graph to do. Although I have to be honest with you, my graphs are never good. So at 0, you'd get R would be 3, right? This is number 3 over here. And then, it's going to remain positive until you get to number 3. And the number 3 is, roughly pi. So I'm going to say, the angle over here, that's roughly the angle 3. What happens? It kind of swings around and hits 0 at that point. So maybe something like this over here. And again, my claim is I can't really say I've drawn a great picture. I know in the answer key they will provide a better picture, but right now I'm kind of ballparking it. So let's take a look at it. And I'm going to shade the area that they want. And to do that, I'm just going to shade this area over here. All right. And again, I'm not saying I've done the best job in the world of visualizing it, but it's probably enough for me to write an integral down now. And what's the integral going to be? Well, let's see. And I kind of remember, and it's going to be an integration. We'll do it one step at a time. The limits of integration are given to me, which makes it so much easier for me. It starts at 0, it ends at 3, and it's going to be 1/2 r squared. That's 3 minus theta. Whoops, sorry about that. 3 minus theta squared d theta. Now on an exam, this would be considered a milestone. In other words, you got a picture down and you got the integral down. Now the final milestone is could you do the integration? So I'm gonna try to do it. So what do you get? 1/2 0 to 3. That's gonna be 9 minus 6 theta plus theta squared d theta. Now what I'm gonna do? Well, I'm gonna integrate if I can. It's pretty easy though. 1/2 9 theta minus 3 theta squared, and then I get theta cubed over 3. Limits of integration go from 0 to 3. I got to do that. That's 1/2. Well, let's see. No, that's 27, right? Minus 27 plus that would be 27/3, which is 9. Minus, let's do the lower limit, 1/2. Well, what's nice about that? Every single term there is going to be 0. What do you get here? Looks pretty simple, 9/2. All right, let's see how we did. And what I mean by that, looking at the answer, and I see it over here and I see the work. They have a picture on the next page. Certainly, I'm not too interested in looking at that picture, but if you are, flip to the next page, you see it. Their picture is clearly better than mine. All right, let's go to the next one. And give me 1 second. And let's take a look. So this one says, find the area of the inner loop. All right, so they provide a picture. They provide a picture, I'm going to take it. And they said the inner loop. So I'm seeing the picture. And I have to understand what the inner loop is. So I think I understand the inner loop. But if you didn't, you'd ask the question. All right. Now remember, typically at Essex, when we give you an exam, the exams they're going to be questions that should be very familiar. There really shouldn't be any questions on exams. That's the inner loop there. So my question over here is I need to find out, what the limits are for that, because I'll be honest with you, the integration just couldn't get easier. And what's it going to be? I just don't know the limits of the integration. So I'm going to claim it's going to be something really simple. It's 1/2 r squared, which is 2 cosine theta minus 1 squared d theta. It's the limits that kill me. So I'm gonna start easy. I'm gonna say, what if theta were 0? What number would you get? Well, what would r be? Well, you would get 2 minus 1, which is 1. I clearly see that. And I'm glad they brought it a picture. Now, next thing I'm gonna do is I'm gonna say that, I'm gonna move forward on that. And what I want to do is I want to figure out when it hits this point over here. And someone's gonna say, well, I'm gonna just ballpark it. No, you're not gonna ballpark anything. What you're gonna do is realize that there, the r would have to be 0. Right, so I'm looking for some value above 0, right? I'm sorry, yeah, one value above, when I say above 0, above the angle, some angle above 0 where the r would become 0. Well, let me write this down then. So if the r is 0, what do I get? I get 2 cosine theta minus 1. Well, it looks pretty easy to solve. Really go back to math 120. That means that cosine theta has to equal 1/2. And again, I'm trying to figure out the limits of integration. So what do you get there? Once cosine theta equals 1/2, well, I got a reference triangle, right? It's going to be 1, 2, √3. That would be a 60-degree angle. And what would the angle be in radian measure? It would be pi/3. So I'm going to say here at the beginning, the angle theta is equal to 0. And here, when it hits that point there, the theta is going to be pi/3. All right. However, I got to notice, but this is only half of the problem. But here's my problem. I just want to say, if I got half of it, I really have the both there because of symmetry. So I'm going to put down 2 times this. And what are we going to do now? Limits of integration is going to be from 0 to pi/3. All right. This is a milestone, by the way. So what I want to do is I want to do the work. We'll look at the answer later. It's going to be 0 pi/3. I have to square that. What do you get? 4 cosine squared theta. Oh boy, I got to do this now, right? Minus 4 cosine theta plus 1 d theta. All right. Now, probably the only thing that's going to really cause me struggle there is that cosine squared. So I want to kind of remind you that, cosine of 2 theta is going to be 2 cosine squared theta minus 1, or cosine 2 theta plus 1 over 2 is cosine squared theta. We've been doing that for some time, by the way. So let's take a look. Gee, I got to multiply that by 4, don't I? Let me put that down for you. So I'm going to multiply both sides of this by 4. And what would you get? 2 cosine 2 theta, right? I'm reducing because, I'm multiplying both sides by 4. That's 2 plus 2, right? All right, I'm gonna try to put my integration down now. And again, we have a key to check. And what do we got there? Pi/3. And I got 2 cosine 2 theta. I'll write that down for you. Now I know it says plus 2 and I got a plus 1, so I'm going to put plus 3 down. Minus 4 cosine theta. D theta. Let's integrate. What do you get? Sine 2 theta plus 3 theta minus 4 sine theta. Again, you're going to hear me say this over and over again. Mistakes happen. So who knows? Maybe we made a mistake. We have a key though, right? So what do you get over here? Well, pi over 3 is 60 degrees, right? And let's see, 2 times 60 is 120. The reference is 60, right? And the sine of 120 would be root 3 over 2. Let's do this. We got 3 times pi over, it's pi, minus 4 times the sine of 60. Well, that's 4 root 3 over 2 now. Minus, we got to do the lower limit. And what's nice about that? Every single term is 0. I got to do this work now, right? What do you get? Well, you get, let's see, pi minus 3 root 3 over 2. I'm going to make one fraction of that. That's a 2. So it'll be 2 pi minus 3 root 3. Put a box in that. And we don't want to do it. I did all that work. I saw the picture and let's see if we got the right answer. Yeah, I got the milestones, right? 2 pi minus 3 root 3. Yeah, we did it right. All right. Let's go to the next page. And, part of this is just reading it. And it says the same picture. It's that figure 115. They want to find the area between the inner and outer loop. All right, let's go back to our picture. Okay, well, it can get tough. So what I want to do is, I realize that it's this other area they're talking about now. It's the area that is outside that loop, right? Maybe I do a different color. Sorry about that. It's the area outside the loop. It's like crazy area, right? So this thing over here, it's everything except for that gray area. I don't want to spend a half hour shading that in, but I think you get the idea. But what I got to do is, I'm going to just find out what the big loop is, and then I'll take away the inner one. All right. So let's see if we can do that. Now I did some groundwork over here, right? So I know where the big loop is starting. I know it starts here and it kind of wraps around. Right. So I know in the integration land, it's going to be really easy to write down the beginning part of it. So it's beginning at pi over 3. I may not know where it ends yet, but I know what the integrand looks like. It's 1/2, right? R squared. Let me put this down for you. 2 cosine theta minus 1 squared d theta, but I have to remove that inner loop. And I just did it. I don't want to have to do that again. I just did it. And what did it turn out to be? 2 pi minus 3 root 3. Over 2. I got to take that away. Right? Did I copy that right? 2 pi minus 3 root 3 over 2. All right. So I gotta do that big loop now, right? So remember, I started here and I'm moving over here. Yada, yada, yada. Keep going. Keep going. I'd eventually get there, by the way. You may wonder what angle is here. I'm going to say that angle there looks like it might be theta is equal to pi, right? So why do you say that? Well, look at it. What is it? It would be R would be equal to minus 2 minus 1, which is minus 3, which makes perfect sense because pi is over here, but now I'm in the opposite direction. I got to keep going, right? I think you get an idea that I got to keep going and 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 going until I hit 0 again. And then I'll get that entire loop, right? So I got to figure that out now. And how do I figure that out? I'm kind of wondering about that. When does the 2 cosine, I'll write this on the side for you. When does 2 cosine theta minus 1 equals 0. Well, the first time it was at pi over 3, it's going to do it again, right? When does it do it again? Well, I want to point out that means cosine theta is 1/2. And I think I've done this in pre-calculus. It sort of looks like cosine curve this. And it's going to be over here somewhere between these two. And what's the reference going to be? Well, the reference would be still that pi over 3, right? So what's pi over 3? 60 degrees. So it's 300 degrees then, right? And what's that in radians? Well, let's write this down. That's going to be pi over 180 degrees. And this is why it's so important that you have pre-calculus skills before taking courses like calculus. And that's going to be 5 pi over 3. Let me see if I did that right. 60. Yeah, looks good. Now, someone could say, you spent a lot of time getting the integration. I got to do it again. And I just can't remember what I did before. We have a key. We'll look at it later. So what I'm going to do, I'll write this on the side. This is pi over 3, 5 pi over 3, 1/2. I need to multiply this out. That's going to be 4 cosine squared theta minus 4 cosine theta. Yeah, it's deja vu all over again. And I think I did this before, right? By the way, let me not forget this, because sometimes I do forget it, and I wonder where it went. We'll worry about that later. All right, you get 1/2 pi over 3, 5 pi over 3. And let's see, do you remember cosine squared theta was what? It was cosine 2 theta, I'll erase this, by the way, plus 1 over 2, right? So it's going to be 2 cosine 2 theta plus 2 plus 1, which is plus 3, minus 4 cosine theta d theta, minus, let's not forget this guy. Get my eraser out, my baby work over here. And I got to do it. And I'll put an equal sign down here. 1/2. That would be sine 2 theta plus 3 theta. I'm going to stop for my advertisement. I do make mistakes all the time. If I make a mistake, I'll fess up to it. Minus 4 sine theta. And that's going to be the limits of integration. We need pi over 3 to 5 pi over 3 minus, let's write this down again, 2 pi minus 3 root 3. I realize people on exams get nervous, even though they might have seen the problem before, and they choke. If you're choking, get off the question, go to something else. All right, let me write this down now. 1/2. Okay, so I have to do a little side work here, and I hate to admit it, I have to do it. So that's going to be 10 pi All right, so let me write this down for you. Well, 5 pi over 3 that's going to be 600 degrees, right? 600. So it's really like coterminal with 240 degrees, which is a reference of 60, and it's going to be minus. Then you're going to get 5 pi minus, well, 300. What would you get there? Let's see. Let me get my eraser. I hate to put that side work. There's a problem with that, though. I hate to tell you that sometimes I've erased something. I can't remember what I had down there before. But if we make a mistake, we'll go back and look at our work again. So we're at 5 pi, right? And that's going to be 300, right? Let me write that down for you. So 5 pi, whoops. You know, 3 into 1 is 60, 300 degrees. That means you got a 60 minus root 3 over 2. So that's going to be minus a minus, which is plus 4 times root 3 over 2 minus, let's do the lower limit. And again, I'm not beyond making errors. I make a lot of errors. And we'll do the lower limit now. Whoops. That's going to be the sine of, let's see, pi over 3 is 60, right? 60 degrees. So 2 times 60 is 120. It's still 60, I mean, reference. And we're going to get root 3 over 2. Plus pi minus 4. Now, root 3 over 2, root 3 over 2. You still get the same thing. Minus 2 pi minus 3 root 3 over 2. Boy, I hope I didn't make any mistakes. I really mean that. All right, I got to put this down now. Equals 1/2. That's 5 pi plus 3 root 3 over 2 minus 1/2. This is minus 3 root 3 over 2. We get a pi there. I didn't make any mistakes there. Then minus 2 pi minus 3 root 3 over 2. Yeah, it's like a big job, doesn't it? Let's see. Let's write this down. 5 pi over 2 plus 3 root 3 over 4 minus pi over 2 plus 3 root 3 over 4 minus this thing. Oh boy, it's really going on, this arithmetic. So let's take a look at it. And we get this and this. And that's going to be, let's see, 4 pi over 2, right? If I do this and this, that's going to be 6 quarters, which is 3 halves. Minus 2 pi over 2 plus 3 root 3 over 2. We get 2 pi over 2 plus 6 root 3 over 2, which is pi plus 3 root 3s. Now, yeah, I really hate doing arithmetic. I really do. And I want to see if I got the right answer. Question is, where is it? Wow. Did I get that? That's a miracle. I kid you not. That's a miracle. All right, let's do this one over here. And again, they provide a graph. And what's nice about having a graph is it saves me time and effort. And I got to do it. So I'm going to say R. Let me go back to black. R is a function of theta. And what is it? It's e to the theta. So I'm going to write this down. I'm going to write down f of theta is e to the theta. I'm doing arc length, by the way. F prime of theta. Well, that couldn't get much easier. Then what I got to do, I'll write down my integral. And the integral, they give me the limits. It goes from 0 to 2 pi. That's this thing over here. At 0, this would be 1. And it kind of wraps around until it gets over there somewhere. All right. Well, 2 pi, what would it be? Oh, that'd be huge. Let me see, 2 pi. Yeah, this is not the complete picture. This is a partial picture. It's a partial picture. It doesn't have to be a complete picture, by the way, but it's partial. It keeps flipping around, by the way, because a 2 pi, you know, a 2 pi, it's going to be a huge number. It's e to the 2 pi. It's off the graph. Let me just see if that's true. 0, pi over 2 would be up there. Pi would be out there. It's a guide. Now, let me just take a look at that. E to the pi, e to the 2 pi. It's always going to be positive. Yeah, it's a partial base. It's not completed out. But anyway, let's write this down. And what do you get there? Well, it's going to be f of theta squared, which is e theta squared. I'm using the Arclay formula, plus the derivative squared, which is e to the theta squared. That's a theta, by the way. All right. I hope they didn't give me something I couldn't integrate. I think I'm going to try this out. And that's going to be e to the 2 theta plus e to the 2 theta, which is e to the 2 theta. Let me keep moving along, see if I can do it. I'm going to say the root 2 comes out, it's a constant. And the square root of e to the 2 theta is e to the theta d theta, limit integration 0 to 2 pi. Can I integrate that guy? I think so. Root 2 e to the theta 0 to 2 pi. All right. What do you get over here? Root 2 e to the 2 pi minus e to the 0. Root 2 e to the 2 pi, e to the 0 is 1. Let's take a look at the k, see if we got it. Bingo, we got it. We did all right. And again, it's given me the, if you want to look at the formulas, you can. The formulas we did in class, though, or in the lecture portion. All right, so number 4 is done. Let's go to number 5. And number 5, to be honest with you, it's I can understand if you haven't seen a question like this before, it might seem rather tricky, but I got to go through it with you. And going through with it is just, I'm looking, I don't like secant, to be honest with you. I'm going to write R is, well, secant is 1 over cosine, right? And I'm going to get rid of the fraction. I'll say R cosine theta is equal to 1. And our cosine theta, I recognize it's just x. So what is this thing going to be? Well, if I were to graph it out, x equals 1 looks like this over here. All right, now I'm going to go back over here, and this is what they're telling me. That the theta greater or equal to 0, less than, again, remind myself, some value a, let me make sure I'm saying that, oh, equal to it, but the a is less than pi over 2. All right, so let's take a look at it. And the reason I want to look at it is, I want to look at this business over here, and I want to start easy. So I want to start at theta to be 0. What would the R be? It would be 1 over cosine of 0, which is 1 over 1. So I would get this point right here. Here's my starting point. Now, by the way, I got trouble when I get the pi over 2. And I'll tell you why I get trouble with pi over 2. The cosine would become 0. So really what they're saying is that the a has to always be below pi over 2. So if I do that, what's going to happen? Whoops, sorry about that. The points are going to keep getting bigger and bigger and bigger and bigger and bigger. And why is that? If you look at it, the cosine function is getting closer and closer to 0. So I'm going to say there's going to be a point over here. All right. Now, I wonder what their question is. Their question is compute the length. Let me point out what the length is. The length is this thing over here. But the point depends on where A is. So let me put this in over here. The point depends on where A is. The point depends on where A is. Now, when A gets closer and closer to pi over 2, the length of that is going to get bigger and bigger and bigger. So what do they want me to do? They want me to compute the length of the polar coordinate in 2 ways, as an integral in polar coordinates and using trig. Well, I'm going to use trig. And the way I'm going to do that, I'm going to say the tangent of A is equal to L over this base length. And what's that? It's just 1. So the length of that is tangent of A. That's all the length is. That's the length. Right. We'll look at the key later, but I want to do also, this integral. And let's write this down. Again, I want to point out the A is less than pi over 2. What's the integration going to be? 0 to A. This is going to be the root. It's going to be tough. It's going to be the function, which is the secant of theta squared plus the derivative of the secant of theta, which is going to be secant theta tan theta. I get my ratio because I got to fit a square in there. Let's do it. The first thing I notice is I could factor out a secant squared. And what do you get there? 1 plus tangent squared theta d theta. All right, I'm starting to recognize something now. And by the way, sometimes things don't work out. If it doesn't, I have an eraser, I'll erase it. What do you get? 1 plus tangent squared is secant squared. So you get secant fourth. Well, I can definitely do that. What do I get over there? 0 to A. And that would be secant, I'm taking the square root of that, by the way, squared theta d theta. Do I know a function that differentiates the secant squared? I sure do. And what is it? It's the tangent of theta. What are my limits of integration? 0 to A. Let's write this down. This will be tangent of A minus the tangent of 0, which just turns out to be the tangent of A. All right, did I get the same answer before? Of course I did. They're both tan A. All right, everything works out beautifully. All right, let's do number 6. I think number 6 might be the last question. And, I'll be honest with you, I lifted this image from the book. I have a really bad headache, and that's why I'm drinking water. Okay. Find the area of the shaded region in the figure enclosed by the circle. Well, the circle I know has an equation R equals 7. All right. So what I'm going to do is I'm going to blow this thing up a little bit. Oh, by the way, I have to put the other thing down. The other equation is R equals 14 cosine 3 theta. All right. So I'm going to blow this up. And I would really love to know what that point is there. And a way to do that, what I noticed is that they both have the same R there. So I'm going to set these two things equal to one another, and I'm going to see if I can figure out the angle for that. So 7, 14 cosine 3 theta, 1/2. I think I've done that before. When does the cosine equal half? When 3 theta is equal to 60 degrees. Now 60 degrees is what? Pi over 3. So theta would be equal to pi over 9. So I want to blow this thing up. And what I'd like to do is, I'd like to do this section here first. And what is that? It's just a circle. So I'm going to write my integral down for that. And what's it going to be? 0, starting here. I'm just doing this read. I know it's only half of it, by the way. I'll talk about the other half later. 0 to pi over 9, right? I did that over there, right? 1/2 r squared d theta. All right. Now, what's the, oh, it's 7. Put that over there. By the way, we're only doing half of the picture. Let me do the next one. Plus, now the curve changes, right? So it's going to be from pi over 9. I want to figure out when this thing here, this red curve here, comes back and hits that. Let's see if we can do that. And what would that mean? It would mean, it's going to be a tough one. It means 0. The r would be 0, right? 14 cosine 3 theta, which means cosine of 3 theta would equal 0. Now, when does the cosine first become 0? At pi over 2. So 3 theta would have to be pi over 2. So what number do I get there? Pi over 6. All right, I got to write this down now. 1/2 r squared d theta. What's the r? 14 cosine 3 theta. This is only half of it. Once I get the number, I must double that. All right, let's see if we can do that. All right, one step at a time. (49 halves d theta). I'm going to double it. And this is the area of interest now. Plus, I got to double this too. So it's going to be pi over 9 pi over 6. We'll look at the answer later. 14 squared, I'll put that on the outside. But when I doubled it, the half disappeared. You know what? Maybe I shouldn't do that because I realize something's going to get lost when I do that. Let me go back up. 2, 1/2, 14 squared, cosine squared. Now was it 3 theta, right? I got to make sure it's 3 theta. Yeah, I got that. All right. Okay, let's simplify it a little bit. And what do you get for the first one? Again, I'm going to do this integration over here. This would be 49. Right, the 2's cancel. Theta 0 to pi over 9. What's this guy going to be? Plus 14 squared pi over 9 pi over 6. All right, let's see if I did that right. And then you remember the cosine square. We keep coming up with this again and again and again. And then just write this over here. Cosine 2u is 2 cosine squared u minus 1, or cosine 2u plus 1 over 2 is going to be cosine squared of u. Let me write that down. And I'm going to clean up in a second. 2 cosine of, oh geez, that would be 6 theta, right? Plus 1 d theta. All right, got to keep moving. I'm going to start doing work. That's going to be 49 pi over 9 minus 0 plus, well, I'm pulling the 2 out. So 14 times 14 over 2, that's 7. That would give me 70 and 28, which is 98. Again, I'm not beyond making mistakes. And then you get cosine 6 theta plus 1 d theta. Get my eraser out. And let's keep moving. See if we can do it. What do you get here? 49 pi over 9 plus 98. Well, I got to do this. This is going to be the sine of 6 theta over 6 plus theta, limits integration, pi over 9, pi over 6. All right, let's take a look. 49 pi over 9 plus 98. I got to do this now. So if you put pi over 6, you get sine of pi. Sine of pi is 0. Minus, not minus, I'm sorry, plus pi over 6. Minus, this is the lower limit now. 98. I get 6 here. I'll do the top later. Plus pi over 9. Kind of nasty, isn't it? And I'm going to do 6 times pi over 9 now. That's going to give me 2 pi over 3. And I'm going to just, convert it for you. So 180 degrees over pi, that cancels off 60, 120 degrees, right? So what's that going to be? Root 3 over 2. All right, let me erase around. And yeah, it's a lot of work. I know that. We'll look at the key later. So I'm going to write this down. 49 pi over 9. Let me see if I can do that. I guess we could divide through by 2, right? So that would be 49 pi over 3. So we did that right. Yeah, 49 pi. Minus, oh boy, I got to do this one too, right? Minus 98 pi over 9 minus, I'll be very careful there, 98 times root 3 over 12. I have to be really careful, by the way. I'm going to combine these two terms together. And that would be minus 49 pi over 9 this is going to be 3 times 49 pi over 9. I'm just doing that. I'll do the last guy. I'll do this guy later. And this guy would give me, let's see, 2 of those, which would be 98 pi over 9 minus, let's just reduce this. This would be what? This would go in, let's see, 2 times would be 6, right? And that would be 49. So minus 49 root 3 over 6. I got to make sure I didn't make any mistakes there. All right, I think I did it right. Let's keep going. It'd be a miracle if I didn't make a mistake, I'll be honest with you. 18, common denominator. 2 times 98, 180, 196. 3 times 49, that's 147. All right, it'd be a miracle if I didn't make a mistake. Oh, it's not even there. Go to the next page. All right, I got to copy that. I don't know if I got that right. I can't remember what I put down. Again, I have little tiny headaches. No, I shouldn't say a little headache. I have a headache. My God, I got it right. I'm glad not to look at my work then. And that's what your goal should be. Now, here's the problem. Again, when I say it's a problem, it's a huge problem. You know, I'm often surprised by how little effort people put into their homework. They often say, "Hey, why would I do that?" Well, you do that to learn. You need to do this. And you do it right away, right? Are some of the problems difficult? Maybe. I don't know. Take a look at them. Did I find this stuff to be difficult? Yeah. I find I have to work on it. I have to think. My head hurts from thinking.